Hello, students. Have you ever noticed how your soap doesn't seem to work well in some places, leaving behind a slimy residue? This is the case with hard water. Let's break it down. Water can either be hard or soft, and it all comes down to how it interacts with soap. Hard water doesn't lather easily with soap, and that's because it contains minerals like calcium and magnesium. On the other hand, soft water, like rainwater or distilled water, lathers easily with soap, saving you soap and time. Imagine pouring soap into a bucket of hard water, the soap just won't do its job. But with soft water, it foams up instantly. So, what's causing this difference? It's the minerals dissolved in the water. Let's explore these further. Now, let's understand what causes hardness in water. The key culprits are calcium and magnesium salts, which can be found in forms like bicarbonates, sulfates, and chlorides. These salts are commonly present in natural water sources like rivers, lakes, and groundwater. When water flows through rocks and soil, it picks up these minerals, making the water hard. In fact, you can find hard water everywhere, from your tap water to natural springs. These minerals don't just make water hard, they also react with soap, forming scum and wasting soap. So, in many places, people need to treat water before using it for cleaning or cooking. Let's talk about one type of hardness, temporary hardness. This type of hardness can be removed by boiling the water. You see, temporary hardness is mainly caused by calcium and magnesium bicarbonates dissolved in water. When you boil the water, something interesting happens. Calcium bicarbonate and magnesium bicarbonate break down into calcium carbonate and magnesium carbonate, which are insoluble and form a precipitate. Here's the reaction in chemical terms. Ca open bracket HCO3 close bracket 2 on heating decomposes to form CaCO3 plus carbon dioxide gas CO2 and water H2O. This is the reason why you can get rid of temporary hardness by boiling the water. It's like separating the hard minerals from the water. It's a simple but effective method. Now, let's discuss permanent hardness. Unlike temporary hardness, this type can't be removed by boiling. It's caused by salts like calcium chloride and magnesium sulfate, which remain dissolved in the water even after boiling. For example, when water directly dissolves minerals from rocks, these hard salts stay in the water. They don't form a precipitate upon boiling. The chemical reaction for permanent hardness might look like this. CaCl2 reacts with MgSO4 to form calcium sulfate, CaSO4, and magnesium chloride, MgCl2. Since these salts don't easily come out of the water, permanent hardness requires a more complex treatment to soften it, such as using chemical agents or ion exchange processes. So, how do we deal with hard water? There are several methods. First, you can boil the water to remove temporary hardness, just like we did earlier. But for permanent hardness, you'll need to use a more advanced method. Ion exchange is a common technique used to soften hard water. This process involves replacing the calcium and magnesium ions in the water with sodium ions, which don't cause hardness. Another method is reverse osmosis, where water is filtered through a special membrane to remove the hard minerals. These methods are widely used in water treatment plants to make water safe and efficient for daily use. So, whether you're at home or in an industry, these techniques are essential in managing water quality. Now, let's look at how hard water affects us in everyday life and in industries. At home, hard water can be a real nuisance. It can cause scale buildup in your pipes, dishwashers, and water heaters, reducing their efficiency. It also makes it difficult for soap to work, which means you'll need more soap and detergent. In industries, hard water can clog boilers, costing companies a lot of money in repairs and maintenance. So, understanding and managing hard water is crucial, especially in places that rely on a steady supply of water for cleaning, manufacturing, and cooking. To sum it up, we've learned that hard water is caused by minerals like calcium and magnesium, and it's divided into two types: temporary and permanent hardness. Temporary hardness can be removed by boiling, while permanent hardness requires more complex treatments like ion exchange or reverse osmosis. Hard water can affect our daily lives and industries, but with proper treatment, we can soften it and make it more useful. So, next time you use soap, think about how hard or soft your water is and how it impacts the effectiveness of that soap. Remember, chemistry is everywhere, even in the water you drink.